Greetings everyone, and happy almost St. Patrick's Day. May the luck of the Irish be with you as you tackle this month's problem. There's sure to be a pot of gold at the end of the rainbow for all who work through it. Without further ado, let's get started.
Today's Math Fix is brought to you by A-SSE.A.2, which asks students to use the structure of an expression to identify ways to rewrite it. Let's take a look at our problem today. Students are asked to help Carlos decide between building a square or a rectangular sandbox for his little brother given certain parameters. Carlos thinks that if he builds his rectangular sandbox with a length that is one more than the side of the square and with a width that is one less, the areas will be the same. Students must help Carlos figure out if he is correct and explain why or why not. So, is he correct? Let's find out. Students might start by simply guessing and checking, or picking a random value for x and evaluating the area of both the square and the rectangle for that value. For example, if a student chose x equals 5 to start, they would see that the dimensions of the square are 8 by 8 units for an area of 64 square units. The rectangle then becomes a 9 by 7 unit figure with an area of 63 square units. So it would appear that these areas are close but not equal. Students might then continue by trying another value, perhaps going with something simple like x equals 1. In this case, they would find out that the area of the square is 16 square units, but the area of the rectangle is 15 square units. Is this just a coincidence that in both cases the area of the rectangle is 1 square unit smaller than the square? At this point, it might be tempting to conclude that Carlos is incorrect because students have found 2 instances where this is the case. Here you might want to encourage students to create a table of values to explore the pattern further. For example, using the values 1 through 5 for x and evaluating for both the area of the square and rectangular sandboxes. Doing so shows that the pattern does appear to continue, but why? Here students might draw upon knowledge of factoring or the use of algebra tiles to model the situation further. Factoring out the 2 area formulas, we can see that the area of the square is modeled by x squared plus 6x plus 9, and the rectangle by x squared plus 6x plus 8. So the equations are equivalent except for the constant at the end, which is 1 less for the rectangle than square. This explains the pattern we were seeing. Using algebra tiles to model this factorization, we can come to the same conclusion, but visually. So it appears that Carlos is incorrect about the areas. They are not, in fact, equivalent. One possible extension, however, might be to ask students to explore the perimeters, as Carlos might be concerned about the cost to frame the sandbox and wonder which might require more lumber. Here, students will find that it appears that the perimeters of the 2 sandboxes are the same. Why might this be the case? Well, going back to the scenario where x equals 5, we can see that to calculate the perimeter of the square, we need to add up 8 plus 8 plus 8 plus 8 for a perimeter of 32 units. For the rectangle, we would add up 9 plus 9 plus 7 plus 7, also giving a perimeter of 32 units. The perimeter of the rectangle can be rewritten as the quantity 8 plus 1 plus the quantity 8 plus 1 plus the quantity 8 minus 1 plus the quantity 8 minus 1. Rearranging, we see that the 1's cancel out, and we have the same perimeter as the square. One final extension might be to ask students if they can find other examples of formulas for squares and rectangles with the same perimeter but different areas. Are there any other patterns they can find?
And that's this month's Math Fix task, folks. There's only one more Math Fix test for this year in April, so we can't wait to share it with you. Until next time.